Hello viewers, now we are to discuss another topics in a statistical subject, that is in a statistics subject in statistics, that is the relationship between variables. The relationship between variables. So we are to discuss this as follows. All sciences, natural, social or biological, are largely concerned with the study of interrelations among variables. Many physical and chemical laws can be expressed in the form of mathematical equations. Is law expressing a relationship among a number of variables. Thus, Newton's laws of motion express relationship among variables such as force, mass, and correlation. A study of interrelation, that is, the study of interrelation among variables, is a major concern of social sciences as well. In the theory of demand, of instance, the quantity demanded of a commodity is regarded as a function of, that is to say, depends on or related to its own price, the income of the consumers, and the prices of related goods. A firm's production function is a technical relation showing how inputs are transformed into outputs. It expresses in mathematical terms the relation between output on the one hand and inputs is such as land, labor, and capital on the other. Relation which can be formulated mathematically involve certain unknown constants called parameters. So thus one of the parameters of interest in the demand relation is the elasticity of the of demand with respect to price. The numerical determination of these parameters is of utmost importance both from the theoretical or practical points of view. If the relationships are exact and the mathematical forms of these relationships are known, it would be possible, at least in principle, to determine the relevant parameters by solving appropriate equations. But sometimes errors of observation or measurement obscure the underlying relationship. More often, we cannot postulate a unique relationship between variables. That is, a particular value of one variable does not always correspond to the same set of the other variables involved. Thus, there is no unique relationship between the height and weight of an individual. For any given height, there is a wide range of weights and vice and the others. So, viewers, occasionally theory only indicates the nature of the relationship but does not specify their exact mathematical forms. Thus, in the case of demand function, all the other theory tells us in that quantity demanded of a commodity decreases, other things remaining equal as the price of the commodity increases. Economic theory does not tell us to whether the relationship can be represented by, say, a straight line or a rectangular hyperbola. Frequently, little is known about the nature of or form of the relationship, or the relationship is very complicated in the form. We are then interested to find an approximate relation which is useful for practical purposes. We are concerned here mainly with the empirical determination of a relation between two or more variables. So, viewers, while non-linear relationship between two variables and the case of three or more variables is taken in another topics. The methods that we are going to describe in the present topics and the next we can be broadly classified into two groups: regression methods and the correlation methods. So viewers, this is the relationship between variables. We have to know and discuss about these topics. In next we have to discuss another statistical topics.